In the last video, I left you with an assignment to try to work this out. This is actually very similar to the example that we did at the end. I'm seeing this combination of what looks like a height function and an integral, but it's not quite a perfect match for my area function because I have a constant lower limit of integration, but I have a variable function, not just x, but sine of x up here. So I'm going to say the related area function would be if I just had the integral from 0 to x of root t plus 1 dt. This function is what I'm getting if I plug in sine of x to that function. If I plug in sine x, that would be putting sine x in here, and that would give me exactly what b of x would be. So b prime of x, this is just going to be chain rule. That's going to be a prime at sine of x times the derivative of sine x. The derivative of sine x, of course, is just cosine x. For a prime of x, that's the fundamental theorem of calculus. When I differentiate an area function, I just get the height function, but I get it evaluated at x. So this is just going to be the square root of, now what I'm plugging in is sine x. So it's the square root of sine x plus 1 times a cosine of x. That is my formula for b prime of x. So b prime of 0 would be the square root of sine of 0 plus 1 times cosine of 0. Sine of 0 is 0, plus 1 is 1, square root of 1 is 1, cosine of 0 is 1, and we get 1. So it does take a little bit of puzzling to fit the pieces together, but it's really just making it fit the formula. An area function is an integral from a fixed lower limit of integration to a variable upper limit of integration, and if you have that, when you take the derivative, you get the height function.